even spotlighting Bart already, rather than doing it halfway through the talk.
All right, Bart, there we go.
Okay, thank you, everybody. So my name is Bart Oldeman, and I am basically redoing a talk that was given 2 weeks ago by Ryan Taylor and Maxime Boissonneau, my colleagues in Digital Research Alliance of Canada, about the CERN-FS experience at Canadian HPC site. So there's part of it where I'm intimately involved, and there's part of it that's more Ryan Taylor's side about the CERN-FS infrastructure. So I'll do my best, but if there's very technical questions, I will have to relay to Ryan for answers. So in case you don't know, we used to be called Compute Canada. So through some reorganization, we now have a federal-owned central office called the Digital Research Alliance of Canada, or otherwise known as the Alliance, which has partners called regional organizations like Calcul Quebec, of which I'm part, the BC DRI group, where Ryan Taylor is part of, and some other ones, and then also member universities, and combined we call that the federation internally. So this is the agenda for today. So first I'm talking a bit about my perspective of the software stack motivations. There's a lot of commonalities with Easy, of course, because Easy was kind of motivated by our work. Then introduction about CVM-FS, some deployment considerations, security, like how secure is CVM-FS from top to bottom, and some of the CVM-FS operations, like how big is the team that actually does the operations of CVM-FS at Canadian sites. So basically in terms of what we are is a distributed organization where we have some clusters distributed across Canada, but also the member universities, combined about 250 technical staff, 18,000 user accounts, so every professor, grad student, a postdoc can get an account on our systems, which is a central database. And we have 6 clusters across the country, but of course that means that there are universities without clusters, but they still have users. So to get some local support, there are people who are employed by the universities and then having privileged access to the clusters and to our ticket support systems. So everybody can help each other, and there's also local support available for those researchers. So in terms of hardware, we're running a little bit behind the time, but the major change happened in 2017 when we wanted newer, bigger national systems. We were replacing departmental systems and university-wide systems. And we wanted them to have a common interface. So when people move from one cluster to another, they will look fairly similar. There may be some small differences, but if you want to run your code on cluster A, you can run it on cluster B with minimal effort. And so we had some clusters that were being built in 2016 to 2018 mostly. Or in the case of Beluga, it was 2019. And then the latest cluster we've commissioned is Narval, which is in Montreal, just in the same data center as Beluga, which was commissioned in 2021, which may say, oh, that's already 3 years ago. This is true. So we've now dropped out of the top 100 of the top 500, and multiple sites are preparing RFPs as I speak. So there should be some renewal happening fairly soon by the end of this year and next year. So the problem that we've been running into over the years before 2017 is that most HPC clusters use enterprise Linux because vendors, we need their drivers, parallel file systems, network, etc., etc. And many of those clusters are running now ancient software, like especially CentOS and Red Hat 7, still being used. I missed Kenneth Soap because it was too early, but I don't know what percentage of clusters of people are still running CentOS 7. We still have some. We just moved on over to 8, but it will be out of support in July, which is like the sword of Damocles. Anyway, so if you just rely on that, you still have very old software, GC 4.8 and glibc 2.17, Python 2.7, now out of support for 4 years. So people move to 8, but even 8 is getting a bit older. And 9 is reasonably new, but we have users who just stick on the bleeding edge and they say, oh, we want Fedora 40 software running on the newest cluster, which I have. Like TC 14 is not even released yet, but they include the bleeding edge, and that's their sort of reason of existence. So it's not always possible, but we decided to make it possible for people to use a reasonable recent amount of software without them having to go through hoops. And obviously having a consistent, easy to use interface as possible across all the sites with optimal performance. This is very similar to the goals of Easy, of course. So we want to have it accessible at every site, reliably and performantly. It should be independent from the underlying OS stack and be tracked and reproducible via automation. And we should also make it easy to use a large and evolving software stack. So the module interface shouldn't be too clumsy to use. So we need, for all national sites, the distribution mechanisms of CVMFS, which is the main topic of this talk. And then we have some things in commonality with the Easy, is that we have the Cinto prefix and EasyBuild for automated installation of modules. And we use LMOD with hierarchical structure to get a module interface that scales well. Now, there's also some differences. I mentioned that in more detail in my talk last year in London. We now have, we just commissioned a new update to our software stack, the 2023 standard environment, where we have similar layers as in Easy. We now have just 2 architectures, sub-architectures really of x86-64, because we don't have any clusters that use ARM or RISC-V or anything like that yet. So we have x86-64 v3 and v4. So basically it's like AVX2 supporting architectures and AVX512 supporting architectures. We didn't dive into getting sub-architectures of those, except for a few things where that's somewhat sensitive, like Bliss and OpenBlast. They have runtime detection of the architecture. But anything else is just either v3 or v4. Like there's anything that's like v2 or v1 that's so old these days that we decided to ignore them. And there's no national cluster with that. There's just a few regional systems that are older than 8 years now that still can't use the new software stack, but they're shortly going to be decommissioned. Then we have a compatibility layer. So that's similar to Easy, but ours is a bit bigger. Like we have more things in the compatibility layer than Easy. That's just a choice what you put where. So we have a very long list in our EasyBuild of filter depths, where we don't want to put that in modules. We only have one architecture at the moment for Gen 2 x86-64 because we specifically decided that anything that's deep performance sensitive will go in the compatibility layer. So at the moment we have the directory x86-64 If we ever get needed ARM or some other architecture, we have the directory space to put it there if we need to. And then we have stuff that is privileged or is OS dependent, so we put that in on local locally on clusters. Sometimes there's legally restricted software that has to be on the local cluster because they don't allow us to distribute it even internally among clusters. So one thing that Kenneth mentioned is libcuda. In the previous talk, we have a somewhat simpler but less flexible approach for libcuda, in that our libcuda is searched for in a directory user lib64 NVIDIA, and that is the location it looks for. So I should look in making that more flexible, but so far it's like if you want to mount our software stack and when you use libcuda, you have to copy some symbolic, or symlink some runtime files into user lib64 NVIDIA, because that's where it looks. We actually interpreted the CUDA EULA slightly differently than Easy and put NVCC in our public stack. And so far, NVIDIA hasn't sued us, but whether we're on the right side, I don't know. We're on the same side as, for instance, Debian, that distributes NVCC in their software stack. So all I'm saying is that the legal question hasn't been completely sorted. We were supposed to be in contact with some lawyers from NVIDIA, but they are too busy and important to talk to us. So Easy just decided to play it safe and interpret it slightly differently than we did. So time will tell. In terms of the software stack, so we have at the moment 1,300 or thereabout scientific applications, over 12,000 applications, including all the CPU varieties, toolchain versions. And as you can see, there's been a continuous growth of software packages. We used to have 4 major generations of x86 CPUs. Now we used to have 2 4 major generations of NVIDIA GPUs. And then there is, depending on an environment variable, the OpenMPI module will choose whether it will be set to InfiniBand, OmniPath, or Ethernet. It will try to auto-detect and then set an environment variable. And then depending on the environment variable, the OpenMPI and Intel MPI modules will decide what kind of fabric to use. We also have 14,000 Python wheels. So basically, apart from modules that have some Python binding included, or a general SciPy stack module, which is similar to SciPy bundle and upstream EasyBuild, we have most Python packages packaged as wheels. So we just tell users, start a virtual environment and use pip install your package, and then it will usually get that package from our wheelhouse instead of from the internet from PyPy. Another thing that we use a lot is the HPC in the cloud with Magic Castle. So we use that always for teaching. Since the software stack is portable, we can just include it in any cloud environment. We use this for hundreds of our training sessions. This is a separate project maintained by Félix Antoine Fortin, my colleague at Université Laval, and this is being used a lot, including by some people in Europe, like Alain Ocais has been working with that quite a bit. And you can even mount our software stack on most lab computers and laptops. Obviously, if they're running Mac OS, it will be a bit harder, but if you're running Linux or you're running Linux on Windows via WSL v2, you can mount our software stack. And you just have to read our wiki and it will tell you what packages to install, and then you can mount it. So that's on the software side. And then what do we do to distribute this? So the quick introduction of CVM-FS. So what is it? It's a file system, obviously, CernVM file system, and it lives in user space, so it is mounted via the Fuse package And so the kernel part is just Fuse, and then the file system itself lives in user space. And the nice thing is that it's really a well-working file system for distributing software. It's kind of, in a way, it's the opposite of a parallel file system that you use on a cluster for user files. There's things like automatic file chunking, deduplication, compression. It will give you access on demand and cache. So if you don't use a particular software, it will not download it over the internet. It uses HTTP data transport. You can use HTTPS if you want, but usually we don't need it because it's public anyway. There's no point securing it that way. It has geographic distributions, and we have redundant servers, which I'll get into in a moment. So the protocol is fairly simple. It uses HTTP using REST. And then there's the data structure with a hierarchical structure of hashes. I haven't studied that in detail. You can look it up. I will send you a link to this presentation. You can look it up in the CVM-FS documentation. All the metadata is encoded as catalog files, so you can the queries are resolved locally, so it doesn't have to traverse the whole tree to find out attributes, file sizes, and things like that. They're all just in the catalog file. So the metadata is data as well. It's immutable and cacheable. We have it. It's good for millions of files, random IOPS, which is kind of the opposite, like I said, of a parallel file system where you want to reduce the number of IOPS. So you stimulate users to not put millions of files in a single subdirectory because that may slow down your file system quite a bit, and really designed for software. But we can also use it for data sets, like I was mentioned yesterday and the day before, like the data repository. So we also have a data repository where we put some data as used, for instance, in bioinformatics. So how does this all work? There's a hierarchical structure for CVM-FS. There is a stratum 0, which is like the central spin spider in the structure. And the stratum 0 is the only place that is read-write. So when we publish software, we push it to the stratum 0, and then we'll have to wait a few minutes before it shows up on the clusters. So basically the software is distributed from the stratum 0 cached to public mirrors, stratum 1s. In Canada, there's some like West and East, for instance. And those stratum 1s are in turn pooled by various clusters. If you can mount directly, if you run it on your laptop, you don't really need a cache. You can just get it directly from the stratum 1, but if you operate a cluster, you want what is called a squid cache. And this way, you release some of the load on the stratum 1 servers, because most of the software is cached on the squid servers on your cluster. So you have scalable performance. You minimize network traffic by having this hierarchical structure of stratum 0, stratum 1s, and squid. So in terms of the operational experience and deployment considerations, it's general robust and mature. We've had very few issues with using CVM-FS. Every now and then there is an issue, though I'll show you that. Much simpler than a cluster file system. It's read-only, no locking, no metadata servers. So that's another point of view of the opposite of a parallel file system like Lustre or GPFS. We can offload the IOPS, so it's easy it's an easy file system in terms of the load on the system. Even we can use a cache on the nodes. So typically our local drives will have a cache on every compute node on the cluster. they're about 50 gigabytes or somewhat smaller. And even with diskless nodes, you can have an alien cache, and that will help on a cluster file system. It's really optimized for use cases that typically challenge cluster file systems. So we have, if you publish your software locally on like Lustre or GPFS, that may challenge your cluster file system, but if you put in CVM-FS, it will usually work much better. If you have like a cluster that has 2,000 nodes, you need about 2 to 3 caching proxies. That works very effective if the client disk caches are persistent and large enough. This is where the disk cache on the node comes in. And for the caching proxies, like I mentioned, we have Squid, Frontier Squid, and GINX are different solutions for the caching on the cluster scale. There are sometimes CVM-FS problems that are caused by node level problems. You get an OOM out of memory problem. I mean, it is happening in user space. It can be killed by the OOM. Sometimes there is exhaustion of file descriptors or PIDs. And yes, occasionally we have a node where we have the dreaded transport endpoint disconnected, and which basically means we have to take that node offline. Could be done automatically by some kind of node health check. And if it happens on a login node, occasionally we have to just reboot the login nodes. Some users won't be happy, but that's life. Sometimes login nodes need to be rebooted. Sometimes people will say, hey, there's a bit of high CPU use on the worker nodes that may cause a bit of jitter. That can happen. We see, like, for instance, CVM-FS2 daemon is using 66% CPU, but still right now we have nodes that have 64, 80 cores, sometimes even 120 cores, so it's still very low percentage on a node level. But of course it can slow down if it's on a core that also runs an MPI process. Usually that happens when something is locally resolving metadata queries, and it's often a sign of users doing interesting, inefficient things. So this will typically not happen when you run your massive MPI program that is not really hammering the file system, but more often when people do stuff in AI or bioinformatics, where they just access a lot of files. There is more visibility because it runs in user space. If you use like Lustre or GPFS, you may not see the percent CPUs, but it may still be jitter. It's just hidden because it's in kernel space. You have to be aware of zombie mounts. That can happen sometimes when people use containers like Aptainer on the node and they do interesting things in those, and then maybe some zombie mounts on top or underlaying or overlaying. Don't have much experience with that myself. And you have to watch out for cache thrashing. Typically what we see is that on our nodes, the compatibility layer, like especially the compatibility that's in current use, like the Gentoo 2023 module, is pretty much permanently in cache. So if I do like cat on a cluster, it's the cat from the compatibility layer. It will be instantaneous. But if I use some command that is more obscure and that hardly anybody else uses, then it has to be pulled down from the Stratum 1 or from the Squid, depending on how recently it was used, and there is a bit of a delay. But if people just use a lot of different software and they go over like 10 gigabytes of software sizes, they may trash the cache. So what happens when something comes down? It can happen that your internet is broken. There could be a squirrel or a groundhog or other animal that bites down network connections. Then what you do? well, a large enough proxy cache will give a little bit of feedback, but it's very dangerous. Like I said, the cat command will continue working, but if somebody runs a program that doesn't exist in the script, then it will just not be there and it will just time out and everything expires after 3 days. So you better fix it soon. So that's not very reliable. Then we have an alien cache, which works much better because it has everything. If you want a script guarantee, you can even preload it, but it's a bit trickier. And it can also be used in conjunction with a local disk cache. The best you can do is to have a local private Stratum-1 server. Like for instance, we have the Beluga and Naval clusters in the same data set, so they're basically sharing a local private Stratum-1 server. So we're not dependent on the internet or on the research network to keep our CVM-FS going. So you want a private Stratum-1 server. You don't need a public Stratum-1 server at every location because you want to have something that is reliable and doesn't get bogged down by other people trying to access the Stratum-1 server. One interesting issue that we saw a few years ago in May 2021, and which still makes me a bit nervous, is in-place updates of libraries. So in general, when you say do an update of glibc, which you sometimes have to do because security considerations, what happens when you update libc.so.6 on your local file system or your laptop, basically whatever program was using the older version has it opened and will have that inode open and just keeps it in memory. And that file is the old version of glibc is not deleted from the hard drive until the last process that uses the old glibc dies. Any new program will use the newer glibc. And that's all happens behind the scenes and is managed by the kernel. It's a very cool fix, and you can see that if you go in a proc directory and find out the inode that's using. You can even restore it from the proc file system if you want the old glibc back. Now that didn't work very well with CVM-FS, and I did an in-place update of glibc with fairly innocent looking change, and then people started complaining and was a huge fallout, and we restored the old glibc to stop random crashing. And so there was something going on which is called cache poisoning, and the SHA-256 sum would just change every time you ran it. And so I've been very careful ever since in updating shared libraries, basically avoiding it by using a symbolic link instead, so that the old library is still visible and will still be, and the maps versus the memory maps versus the old version are still visible. And then have the new library installed via symbolic link. It is fixed in CVM-FS 2.10.0, but you have to make sure that all the clients use that version. That was released a few years ago, so it should be fine at the moment. I'm still a little bit nervous. So generally, in-place updates should be fairly rare. If they are just binaries, they're not really a big deal, but if they are shared libraries, Kafit, Emter, be very careful. The next part is security. Security has many facets about it. Confidentiality, which is typically not very applicable to CVM, is all public, but we do have licensed software with redistribution problems. Just the license doesn't allow us to redistribute it to the public. Examples are, for instance, the Intel compiler, MATLAB, NVHPC, a whole bunch of them, that we can distribute internally, but not to the whole wide world. And so we put that on a separate repository called CVM-FS/restricted.computecanada.ca. And in order to mount that repository, you have to be allow listed by us. You need to we require agreeing to a policy. You need the LDAP for identity synchronization, and we set a setting in CVM-FS claim ownership is no to preserve the file owner in the group. Basically, most software that we installed in the restricted repository doesn't have special owners or groups. You don't it means that the clusters can see it, but if you mount it on your laptop, you don't see that software. That's the case for MATLAB. The binaries are visible, but some people still can't use it because they need to bring a license. So some of our clusters have a MATLAB license and they can use it. Some don't, and they cannot use MATLAB even though they can see the files, but it's not a big deal. Some other software you have to require, the users need to require to a policy. So we say, for instance, for Gaussian, they need to agree that they're not writing competing software. And if they say yes to a number of questions, we add them to a soft Gaussian POSIX group, and then they can access the software in a restricted repository. The other thing is more a chain of trust is how can you trust our software when you mount it on a cluster or on your own computer? Could there be crypto miners that are injected into the cluster via CVM-FS? Like how do you trust the end-to-end links? So we deliver over HTTP. There's not any security to be had by using HTTPS, but the chain is only as strong as the weakest link. So one thing is like if you get the release RPM, like if you mount your CVM-FS, does it work? Can the RPM be trusted? So you try to install the RPM. Well, at the moment, this is no longer necessary. You can, and we have the repository set in the config repository from CERN. But even if you do that, it's like, do you trust us? And you have to say, the fingerprint set by Ryan Taylor, is this okay? Yes or no? And you're like, what do I do? Do I press yes or no? And I mean, most people, in my experience, just will press yes because they think, oh, this looks fine enough. But if you're extra thorough, you go to a Git repository or a wiki, and you make sure that that fingerprint is actually genuine and matches with what you see on the screen here. It's basically the same thing as when you put install software and you want to double check that the SHA-256 sum is actually correct for when you install a piece of software. You can double check that with the value that's given on the website that distributes the software. Often it's not there, so you just have to trust it and generate it on the fly. So then you install that config RPM, and it contains the public key of the CVM-FS configuration repository. There's a master key, and then who is allowed to sign the repository manifest, which contains the hash of the Merkle tree root. And here's a link to CVM-FS security considerations. That's just from the CVM-FS documentation, which tells you how this all works in case you're interested. So it distributes the public keys of all the other CVM-FS repositories. That's a repository in CERN, the configuration repository, and it has our repository, the soft.computecanada.ca repository, and also the EASY repository since about a year or so. So apart from that, the other thing we have to deal with is DDoS attacks. Of course, like any other web server, you can be attacked by distributed denial of service. That's just a fact of life. They are massive, And how do you deal with that? Because it can just bring down your Stratum 0 or your Stratum 1 because they have a public HTTP address. And so what we do is we do it in the network. So basically there are peering solutions by commercial CDNs, content delivery networks. So they're, from what I understand, what happens is that you can say have a contract with Cloudflare, some other CDN like Google, and they can basically absorb the attack through peering. So basically, we do that, and it's this research network peering with a CDN provider that makes you part of a larger network, which can absorb the DDoS attack. And that improves access for anyone, anywhere, just by absorbing the distributed denial of service. So then in terms of how many people does this involve? So in terms of the 6 national systems, there are separate teams that install the software and the teams who are working on the CVM-FS infrastructure. So there's about 40 staff members that can publish software. We have 4 core members of those, including me, Maxime, but also Jacques Lomp and Doc Roberts, who are on the software part of the research support national team. And then there's about 35 other people who can publish software, some more than others, and they can push software to the Stratum 0. So that's like the software part, which I'm an integral part of. And then there is the CVM-FS national team, of which Ryan Taylor is part of. They have about 8 members. They are only part-time on the CVM-FS national team. We have a total FTE about 1.5 person. Ryan is doing a lot of that work, but of course, on every cluster, there's somebody responsible of managing their Stratum 1, their squids, local amounts of CVM-FS, so they just do that as part of their sysadmin job to make that work properly and efficiently. And they meet every week or so. The CVM-FS national team has their member meeting. So I'm not part of that meeting because we have actually the software meeting and the national team CVM-FS meeting. They happen at exactly the same time, so you can't even be on both meetings unless you make an exception. So the location, I've already been into that. Those are our 6 national clusters. Our boot is for cloud, and then the 5 traditional HPC clusters, of which one is with special Niagara, which is optimized for large MPI jobs, so you can't run partial node jobs on those. They're just like full node large MPI jobs, and the others are general purpose with GPUs and other things. So when you see that in Canada, the design is that most sites have a local Stratum 1.0. So you see that Victoria with the Cloudy or Arbutus system has both the Stratum 0 and Stratum 1. Our build node is also there, and we basically connect to the Stratum 1 from there. And then when you look into Stratum 1, they're geographically distributed. So every cluster site has a Stratum 1 server. Vancouver, Waterloo have one. Montreal has one for the 2 clusters that are in the same data center. Toronto is a little bit differently because their nodes do not have a local hard drive, no SSD either. So they're using an alien cache, which basically removes the need to have a Stratum 1 because they have everything already in their alien cache. And then in terms of the publication, we have a dev software repo and a prod software repo. So we can publish software first on the development repo and then can test it via either Aptainer or via proot and just fake software openers to get their software from the dev repo instead of the prod repo. Sometimes when we publish like a new module that nobody else used before, we can just go straight to prod because because nobody else has used it before. The module is visible, so then we can skip it. But when we modify something in place or we add something to Gen 2, we typically test it first on the development, just to make sure that everything's working. But if you mount it on your laptop, you typically just mount the production repository. We have the accessing CVM-FS documentation, so that's basically what you can use to mount it on your laptop. So that's about it on my talk about the CVM-FS. I should check the clock. It's 10:30. I think I'm about in my allocated time. I have some time for questions. Thank you very much.
Right. Thank you, Bart. Any questions for Bart or his colleagues? And can you pass the mic?
Thanks for a very interesting talk. I'm wearing, as you can see, my let's get a little bit interesting hat.
Jörg, if you come here, he can see you.
Oh,
I can see you already in the
Okay.
background.
Okay, as you can see, I'm wearing my let's get a little bit interesting hat, and I'm playing a little bit devil's advocate on a good reason, I hope. Security. What I've learned the other day is some firewalls are doing deep package inspection, and they can inspect packages which are actually coming via SSL. How can we make sure that one of the Stratum 1 servers doesn't get corrupted? So instead of having a good version of, XZ installed, you've got the bad version of XZ installed, if you see what I mean. Simply by when you transfer the data from Stratum 0 to Stratum 1, that data stream gets injected with a kind of man-in-the-middle attack, and the packages get replaced with bad ones, and then you've got a polluted Stratum 1, which then obviously fans out to all the universities. I take my hat off now.
Okay.
This is something that CVM-FS basically doesn't allow. It does end-to-end
Yes.
checking.
Exactly. So basically, this is part of the overall security of CVM-FS that I looked in the chain of trust. CVM-FS security considerations. So that's kind of the hash of the Merkle tree root and all that. Everything's designed so that it has to work with the signing keys. And things will just not work if the hashes don't work.
Now your comment is still relevant because I think they've seen this in Groningen, was it? Yeah, where this packet inspection thing says that one of the data blobs that are being obtained from the CVM-FS server into the client has something malicious, and it's just a false positive.
Yeah,
it
we've
blocks
seen
that
that too.
package, and then CVM-FS has no way of dealing with that. It's just
Yeah.
missing data. So you basically have to whitelist that kind of transfer and make sure you don't get any interference there. We've seen things like this happen, and we looked very closely about what was going on, and I think it was like a Python script or something. There was nothing malicious going on at all.
Yeah, I can't remember exactly what was having an issue on our cluster, if it was CVM-FS related or something else, but we've had over-eager deep packet inspection causing issues at times as well. And we really had to talk to campus IT to basically say, yeah, please guys, whitelist this because you're hurting more than you help by this deep packet inspection.
The thing I had in mind is a few years ago, we had this solar flare problem, if you remember, where actually the repository got hacked. And then, of course, when they dished out all of the software, all of that was compromised.
What actually happened there is their build system got hacked. So
Okay, build system.
it's like they managed to inject something in our build bot, which then happily build something that we happily ship in easy. So it is something to be aware of. Yeah.
Yeah, this is really the chain of trust. It's always like, I mean, just thinking about the XZ vulnerability, it was social engineering basically. You you know, it's you can have all the technical checks in place. If a malicious maintainer is there, they can just do what they like.
There's a question in Zoom as well from Richard. Any recommended monitoring tools? That's a very generic question, but I guess he's asking specifically about CVM-FS. So I guess you guys have detailed monitoring on like Stratum 1 server, Stratum 0, bandwidth usage, disk usage, all these type of things. That's maybe something we could sync up on.
Yeah, that's something to relay to Ryan because he's intimately familiar with how these things are set up. Like I know about the monitoring also on the compute nodes, for instance, that you have to monitor if the file system is not mounted correctly. So you need to node health checks.
Yeah.
So otherwise they are going to be black holes in terms of jobs.
Yeah. Yeah, Richard, I'm not sure that answers your question. If it's specific about CVM-FS or more other things, maybe you can clarify.
Ryan is in the Easy Slack, so if you want to ask there, that would be the best. Yeah.
Okay. It was for CVM-FS specifically. Yeah, that's definitely a good question. Ryan is in the file system layer channel of the Easy Slack, and he's very helpful. If he answers, it's going to be a very good answer. I already know. Any more questions for Bart? Maybe I have a bit of a nasty one. I could have mentioned this up front, but are you aware of any missing features in CVM-FS that would be very nice to have with all the, let's say, decade of experience you have with running that service?
That's an interesting question. There's nothing that popped up at the top of my head.
But maybe that's also a better question for Ryan and for you, but I'm sure he has a wish list, but nothing specific.
Not after they fixed the ACL and those parts actually working.
Sorry, I don't hear Alka very.
Yeah, not since the Fuse 3 handled the ACL handling. After that, everything is perfect.
So it's finished. There's a finished open source project out there. Yeah.
Okay. Yeah, I'm sure there are things popping up. I mean, we had the in-place updates. That was a pretty scary bug when it happened.
And they fixed something there, but I think they cannot hard guarantee that it's never gonna pop up anywhere.
Exactly. Yeah. So that's kind of what makes me a bit nervous about those. Well, sometimes now do like a glibc update. I just sometimes when it has to happen because of some security issue. I mean, we're kind of insulated from security because all the set UID root escalation that doesn't apply. But sometimes there's clients that you can have like a PNG vulnerability that can cause a picture to blow up remove all your files or something like that. So yeah, because it doesn't apply to symbolic links, you can just have like a libpng.so, and then you just put a suffix on that file, and then you change the symlink to put to the new version. That is safe.
Maybe a question related to that. So I'm not sure what your longest lived compat layer is, but how much of a pain has that been to keep that up to date from a security updates point of view? And then mainly talking about glibc, like how long does Gen 2 keep glibc properly maintained and backporting?
Well, yeah, that's a good question. We basically say use as your own risk for the older stack. Yeah. So the older stack has software from September 2016, and we basically when people can still use it, we haven't deleted it, but when people load it, we say there are known security vulnerabilities, use at your own risk.
Yep.
So it is basically, it's the same, it's exactly the same if you download some container from 2016 and you start using it. Yeah, you know it's at your own risk, but in this case, we're not the one downloading the container, but we're just saying, you know, you can use it, but don't blame us if it starts deleting your data.
Yep. And have you talked to the Gen 2 maintainers about this at all? Like asking for some kind of extended support, or if there is a way that we could try and
No,
keep
I
certain
haven't.
versions a bit more long-lived, like a long-term support?
Yeah, I mean, Gen 2 is very fast moving, so
Yeah.
but if there's some CVE, usually, I mean, I can just go in our overlay and get the most recent version of Gen 2, or sometimes if it's like a fairly self-contained patch, you can just apply the patch on your existing version.
How much testing do you do when you install updates like this in the compat layer? You have test suites that you run?
No, I do a sanity check really to make sure it works.
So nothing is absolutely horribly broken, at least.
Yeah.
Okay. Good.
Yeah, that's one thing Easy does better in terms of the testing. Is how we try to borrow a little bit back from you guys. And the same thing like for the 2023 iteration of Gen 2, I bootstrapped it using the Easy bootstrap container, and then I built from there once it was working. Yeah. I should share. I should mention that because I forked the Easy compat layer and then worked on that script there. But the differences are fairly minor. So
there's a question from Thomas if you've tried Easy on your systems.
Actually, I haven't yet. I have used it only on my laptop so far. Easy. I will have to talk to the sysadmins to make it visible, because at the moment our configuration doesn't make it show up yet on the
you have
in CVM-FS.
You have specific repos explicitly whitelisted to show
Yeah,
up.
exactly. Yeah.
Yeah. Okay. So you're blocking the competition.
Yeah, I know, but I mean, I mentioned it once in our Slack, and they said we're open to it. So we will have it available at some point.
Yeah, it could make sense. The more systems we're on, the happier we are.
Yeah, exactly.
Yeah.
Yeah, especially ever since it shows up in the general config repository. So
Thomas says it's parent denying its child. Yeah. It's Easy is very much inspired by what you've been doing in Canada. Yeah. Okay. Yeah. Unless there's more questions, I think we can wrap up here. And I think that means it's beer o'clock here at the end of the user meeting. Thank you very much, Bart. It's very nice that we can keep this an ongoing conversation between these projects, and we're absolutely not competitors at all. Yeah, there's a lot of back and forth, and
yeah, exactly.
I like that a lot. Yeah,
yeah,
thanks.
Me too. Okay, thank you very much.
It's beer o'clock for you as well, Bart.
oh, early beers for me. Okay.
Yeah. All right. Thank you very much, Bart.
Okay, thanks.
That's what you paid for.
Right.